Hi, I'm Ayça Çayönü, and I study Electrical and Electronics Engineering in Bilkent University. I'm from the Physics 101, Section 7. In this experiment, I studied projectile motion using a slow-motion video and range measurements at several launch angles. My goal was to determine the initial speed of the projectile and see how the horizontal range changes with angle. This is the setup I used. I placed the launcher on a stable surface, used the same projectile ball for every trial, and put a meter stick in the camera's view so I could calibrate the distance later. I recorded the motion in slow motion mode to capture a smooth trajectory. For the video analysis part, I launched the ball at a nominal angle of 30 degrees. I made sure the camera stayed still and captured the full path of the projectile. Here's the video imported into Tracker. First, I calibrated the scale using the meter stick. Then I marked the position of the ball frame by frame to get the x and y coordinates of the motion. After tracking enough points, I switched the graph to y versus x to see the parabolic shape. Then I applied a quadratic fit. These are my fitted parameters. Using these, my calculated launch angle was 33.5 degrees, and my initial speed was 35.06 meters per second. So even though the launcher was set to 30 degrees, the experimental angle came out slightly higher, which is normal because of camera angle and calibration limitations. For the second part of the experiment, I measured the horizontal range of the projectile at several launch angles. For each angle, I took 2 measurements and calculated the average. These were my results. The theoretical formula for range is this. According to this formula, the range should be largest when theta equals to 45 degrees. And that's what exactly I observed. My maximum range was at 45 degrees. There are also symmetric angle pairs, like 20 degrees and 70 degrees. These pairs have the same value of sinus, so in theory, they should produce the same range. In my experiment, the values were close but not identical, mainly because of air resistance, differences in launch height, and human error in measurement. To sum up, the experiments confirmed the expected behavior of projectile motion. The parabolic fit and range measurements followed the theoretical model quite well. My angle and initial speed calculations matched the motion seen in the video, and the range data showed the expected peak at 45 degrees. Small differences between symmetric angles came from real-world effects like drag, air drag, and measurement uncertainty. Overall, the experiment was successful and the results were consistent with theory. Thank you for watching.